Welcome back, Mr. Munyon here with activity 14-2. We're going to continue on with special segments and triangles. Today we're focusing on medians with this lesson. So our goal, whoops, wrong one. There we go, 14-2. So our goal is to determine the point of concurrency for medians. Obviously, we need to know what medians are, as well as use the point of concurrency for medians to solve problems. So just like 14-1 when we did with altitudes, we need to find the point of concurrency with medians. We're going to do some algebra on this as well. So on the last lesson, we did learn what altitudes were. Here's an example of what those ended up looking like. We got our point of concurrency at 1212. We're going to focus on medians now. So I've already got some drawn here, but how do we go about finding those? So let's get rid of the ones that are on there. All right, so a median is of a triangle is a segment that goes from a vertex to the midpoint of the opposite side. So we should be very, if we can find the midpoint, just using the midpoint formula or averaging the x and averaging the y values, we should be able to connect the vertex to that. So the average between 0 and 36 is 18, and 0 and 0 is 0. So this should be at 18. So 10, 12, 14, 16, 18 should be right there. And then I could connect those. All right, and that would be at 18, 0. For AC, average the x value, so 0 plus 12 divided by 2 is 6. Average the y values. 0 plus 24 is 24 divided by 2 is 12. So at 6, 12, we should have another one, 2, 4, 6, and 12. Now connect it to the opposite vertice. Let's go ahead and draw that one. And for the last one here, we can average the x values and y values to find the midpoint. 12 plus 36 is 48, divided by 2 will be at 24 for the x coordinate. The y coordinate, 24 plus 0 divided by 2, so 24 divided by 2 will be at 12. So 24, so 10, 20, 2, 4, and 12 should be the midpoint. That's on the line. Looks like it's in the middle. Connect it with this opposite vertice. We should get all three of our medians drawn. There we go. Got the last one drawn. And as we could have expected, we do see that it does look like they meet at a point of concurrency here at, what is this, 12, 14, 16, and 8. So it looks like the point of concurrency would be 16, 8. But let's check this algebraically like we did. So let's call H the midpoint of AC. So H is the midpoint of AC. Whoops, that'll be this piece here. N is the midpoint of AG. So this one will be N. And E is the midpoint of CG. So this one will be E. So I guess we could go ahead and put that there. All right. Now that we have those coordinates for H, N, and E, determine the equation of the median EA and show your work. So EA, this one should be easy. Y equals mx plus b will be an easy way to do this one. Whoops, I guess I could use a lowercase b for that one. So the slope I can get with the rise and the run. So luckily A is at 0, so the rise y value goes up 12 and over 24. And so the slope I can plug in is going to equal 1/2. And to get the y-intercept, I know that this is a coordinate 0, 0. It crosses the y-axis at 0. So luckily this is just going to be 1/2 x. Y equals 1/2 x is the equation. So that part was easy. Let's see if we can't determine the equation for a couple of these other ones as well. So GH, so GH is here. This one we're going to have to figure out the slope from two different points. It's not going to be quite as easy. And we don't know the y-intercept either, so we may have to solve for it using slope-intercept form. So first thing is the slope. So my y values changed from here to here. It went down 12. And my x value from 6 to 36 went up 30. Both of those are divisible by 6, so I get negative 2 over 5. So negative 2/5, sure enough, 2/5, 2/5, 2/5. That is the correct slope for that one. So now if I wanted to start writing my equation, I could plug in an x and a y coordinate from either one of these two right here, and my slope so that I could solve for the y-intercept. So I'm going to make this one really easy. I'm going to use this one that already has a 0 in it. So my y value right there is 0. My slope I just came up with is negative 2/5. My x coordinate is 36. So 2/5 of 36, multiply top times top, bottom times bottom, so 72/5 there. I get 0 equals negative 72/5 plus b. So you have to add 72/5 to both sides. So positive 72/5 equals b. And that's going to be about 14 2/5. So 14 2/5. Or about, no, exactly 14.4. And that does look like the correct y-intercept. So there's 2, 4, 6, 8, 10, 12, 14.4 should be somewhere around there. So that does look like the correct y-intercept. So just to make it a little bit cleaner, now that I know what this is, my slope was negative 2/5. I'm going to end up with y equals negative 2/5 x plus 14.4. All right, same thing for Cn, the equation. First thing I need to do is figure out the slope. So let's go ahead and figure out the slope first. For Cn, changing y from c to n goes down 24. And changing x from 12 to 18 goes up 6. So both of these are divisible by 6. I get negative 4 over 1, or negative 4. So I know the slope now. So if I started to plug into my equation, y equals mx plus b. Same thing, I'll plug in a point for the y and the x coordinate, and I'll plug in the slope. So the y value I can plug in here is 0. The slope is negative 4. The x value is 18. All right. So then from here, I get negative 72. And add 72 to both sides. So once you finally have solved for b, you know your slope and your y-intercept, so you can go ahead and write your equation for this one. And 72, is that reasonable? Yeah, it is pretty steep here, and these are counting by tens on the dark grid line. So 10, 20, 30, 40, 50, 60, 72. Does look like it will be pretty high up there for that one for our y-intercept. All right, so for number 6, it now says determine the coordinates of the intersection of A, E, and Cn. So that's actually the first one and third one we did. So looking back here, AE was y equals 1/2 x. So here we go, y equals 1/2 x. And Cn was the last one that we did here. Y equals negative 4x plus 72. So these are easier equations because I definitely didn't want to use the negative 2/5 and plus 72/5 or whatever that was, a bunch of ugly fractions there. I should be able to set these equal and solve pretty easily. So if I know what y equals in one equation, I can substitute it into the other equation. So I can start with negative 4x plus 72 equals 1/2 x. If you want to get rid of the fraction, you could just multiply everything by 2 now. I'm going to go ahead and do that. Multiply both sides by 2, so I'll distribute both of these. The point of multiplying by 2 is to just get rid of the fraction there. So then add 8x to both sides. And divide both sides by 9. And we end up getting 16 for x. Once we know here, we can plug it back into any of those two equations and solve for y. So this is probably a pretty easy one to do to plug in for. Let's go ahead and do that. So y equals 1/2 of 16, which we just got right here. So y is going to equal 8. Now that I know my x and my y coordinate, I should get the intersection is at 16, 8. Once we've found the intersection, we can verify that that point is also on the other equation. So although this is an ugly equation, I should be able to plug in these two coordinates and make sure that they work. So y equals -2/5 x plus 14.4. Or you could use 72/5, whatever you wanted to use for your y value. You wrote it in 3 different ways. Let's go ahead and plug in the points here. So y is 8 equals -2/5 of 16 plus 14.4. I should probably use the fifths because this is going to end up in fifths here. So I'm going to, instead of using the 14.4, I'm going to use 72/5. Alright, so I get 8 equals -32/5 plus 72/5. So -32 plus 72 gives me 40/5, positive 40/5, and 40 divided by 5 does equal 8. So it is a solution set. This coordinate is a point on this equation here. So I don't know why I did it here. That's actually supposed to go down there. All right, now that we have proven the point of intersection of two lines and checked that point to make sure it's on the other one, explain how algebra demonstrates the three medians are concurrent. Well, we found we solved the system of equations for one and then checked to make sure that solution set was on the other one, so that point has to be on all three lines. We've proven the point of concurrency is on all three lines. Okay, so Al wants to be certain that medians are concurrent for every triangle. So basically, no matter what triangle you draw, there's going to be one point of concurrency where all three lines meet. Use geometry software to draw a triangle, its medians, then drag. Okay, let's go ahead and do that. We'll use the same software we did last time. Here we have GeoGebra. I went ahead and created the same thing we did before, and I've already drawn a midpoint connected to the vertice, midpoint, vertice. If you want to pick another, if you wanted to do another midpoint, you can go down here to, oh, there it is, midpoint. So select 2 points to find the midpoint, there and there. Once I found the midpoint, I can just connect that with a segment to the opposite side there. All right, so it goes through there. Obviously, that's what we just came up with at 16, 8. But if I was to move some of these coordinates around, is it always going to be one point of concurrency? Whoops. All right, so if I took and moved this, notice the point of concurrency. All three of those medians are always going to go through there. All right, so let's put this back there and go back to here. So the medians always remain concurrent. Yes, that was fun. Is the point of concurrency always inside of the triangle? Maybe some of you guys noticed that, in fact, it is always inside of the triangle. Notice no matter where I put this on the screen, point F, where all of those meet at, is always going to be inside of the triangle. So over here, inside of the triangle. I try and put it on the other side, inside of the triangle. You can't make this one be outside of the triangle. So yes, it's always inside of the triangle. Okay, where this point meets at is called a centroid. What are the coordinates of the centroid? We just came up with them at 16, 8. And we can call that point R. So I went ahead and, there we go. So now it's point R. So a centroid's location has a special property related to the segment lengths. So it says use some geometry software to draw the triangle and its medians. We've already done that on GeoGebra. And let's find some links from, looks like CR, from the vertex to the centroid, and then from the centroid to the midpoint of that opposite side, and compare them. So if I was to find the distance of these, and I pick two of these, so I get 16.5, and if I did it again, I get 8.25. Notice I already went ahead and typed those in for you, but that's interesting. That looks like it's those might be related there. If I did that for the other pieces, the distance from the vertex to the centroid and from the centroid to continued on to the midpoint, you'll notice there is a relationship between all of these. 10.77, so 20 and 1.5, I get about 21.25. All of these, the distance from the vertex to the centroid is twice as much as the distance from the centroid to the midpoint of the rest of that median. And just looking at it, you can tell this is about twice as big as this piece right here. This is twice as big as this piece. So we could verify that, which I already did. Here's the numbers that we'd get if we found the distances for the rest of them. That's always going to be true, not just on this example. That's one of the special properties. So compare the lengths. What relationships do you notice between the distance? Blah, blah, blah. They're all twice as big. Okay, so then we can actually go ahead and write the centroid measure theorem. So this is important right here. It says the centroid of a triangle divides each median into two parts so that the distance from the vertex to the centroid is twice the distance from the centroid to the midpoint of the opposite side. And once again, you're going to need to remember this for the check your understanding questions down here, as well as homework questions that we have. So the last question we have before the check your understanding says create any triangle on construction paper, locate the centroid, cut out the triangle, and balance it. Another property that isn't tested, but it's a fun fact, especially if you're in construction, more design than anything, is that the medians create a centroid, which is also the center of gravity of a triangle. So if you found the centroid of a triangle, you could balance it on that point. So like if you had a triangle here, you could literally balance it. This isn't a triangle, but without having to guess and move your finger around, you'll know exactly where the center of gravity is on that triangle. All right. We're not going to do that. It's kind of fun, but takes a little bit of time. So check your understanding. Pause here, see if you can figure out 16 through 19, then restart your video so we can go over them. All right. Hopefully you took a moment to try and solve 16 through 19. Can an altitude of a triangle also be a median of a triangle? So to be an altitude, it goes from a vertex and has to be perpendicular. To be a median, it needs to go from a vertex to the midpoint of an opposite side. So if an altitude goes to a midpoint, then it would be a median. And when can that happen? Well, if we have an isosceles triangle, then the altitude would go, like if I drew perpendicular to the side right here, it would go to the midpoint of that side. So conveniently, yes, it could be. Yes, if the altitude went to a midpoint, then it would be. Okay, for questions 17, 18, and 19, it was just determine whether these statements are always, sometimes, or never true. Draw sketches to support our answers. So the medians of a triangle bisect each of the angles of a triangle. So do medians bisect the angles? Well, it kind of looks like they do. So definitely sometimes, like in this example, I'd cut this exactly into two congruent angles. So it's at least sometimes. It's not going to be never. But is it always true? So like this example kind of looks like the angles are bisected. Probably be best to check on the GeoGebra. Move that puppy around and see if we can make it not work out. So here, looks like I have two congruent angles. You know, maybe this piece This angle, maybe this one's a little bit more. How can I check for sure though? Let's move this around and oh, definitely I see that that angle here is now way smaller than this one. So this median from A to E is not bisecting this angle anymore. So that's not always true, but it's definitely some point true. At some point between here and here, you're going to have congruent angles. So sometimes true for that one. Okay, so that one is sometimes. All right, what about the centroid of a triangle lies on the interior? We've already talked about that one. I think that was one of the other questions up here that we did. The point of concurrency is always inside, yes. So it's always going to be inside on the interior of the triangle. So that one is always true. What about 19? The centroid of an equilateral triangle is equidistant from each of the three vertices. Okay, so an equilateral triangle. Let's see if we can't create something that looks close to an equilateral triangle and look at the distances here. Oh, there we go, distance. So from here to here, and from here to here. So it looks like they're actually pretty close right now. Maybe not perfect. You know, maybe I should have had this one. Yeah, I keep trying to find the distances, but I'm not moving these. So somewhere around here, like this is really close. 4.4, 4.4, 4.4. Looks like an equilateral triangle there. I would definitely say if it's exactly an equilateral triangle, these would be exactly the same. Obviously, I'm not making this perfect, but this one, it is always true for that one. All right. Now we have some practice. Same thing as before. Pause here. Practice these using the centroid measure theorem, and then turn your videos back on and check your answers. All right. Now that you've had a chance to practice, let's look at this picture, label some stuff, see if we can't get 20 through 22 pretty easy. I'm going to do number 24 for you guys, and then you can, I'll just put the answers up for the other one so you can check your work. And if you get stuck on one of the steps, you can go back and see how we did number 24. All right. So for number 20, it says if EU equals 8, so EU equals 8. What is YU? So the centroid measure theorem says that the distance from the vertex to the centroid is twice as much as the distance from the centroid to the midpoint. It does tell us this is a centroid, so this would be twice as much, 16. So YU, or UI, is 16. And then the whole thing is 16 plus A is 24. Okay. For number 21, let's use a different one here. If BS equals 12, so if the whole thing equals 12, from B all the way to S, then what is BU? Okay, well this, I don't know what it is. This, I don't know what it is, but whatever this is twice as much as this piece here. So the whole thing is 3x divided by 3, you get x equals 4, so this will be 4, and 2 times 4, 8, which makes sense because it does need to be twice as much here as it is here, and it does add up to 12. So then BU would be 8, and US would be 4. So I did that one really easy with some segment addition, and the relationship was this was twice as much as this, so whatever this is x, this is just going to be 2x here. On the last one, number 22, if TU equals 10x, and then what is AU? So we don't actually have values on this one, so AU would be twice as much, 20x, and AT would be the whole thing, 30x. That one wasn't too bad at all. That was actually pretty easy. All right, so now let's look at question number 24. And to do this one, we're going to go on a different page here to have some room to work. So we have some coordinates here, 6, 0, 2, 8, negative 2, 2 for x, y, and z. It says find the coordinates of the centroid. So we're going to have to find all the midpoints and then either draw or use algebra to calculate the intersection of those. So here, I've gone ahead and labeled coordinates x, y, and z. And let's see if we can't find the midpoints. So the midpoint of positive 2 and negative 2 is 0 for the x-coordinate. For the y-coordinate, negative 2 plus 8 is 6. 6 divided by 2 is 3. So at positive 3, I've already got one labeled there, so at 3. And then from here to here, I can connect those. It looks like rise of 3, run of 6, but it's going to get connected right through there. Not perfect. All right, let's do another one here. Let's try these. To average the x-coordinates here, 2 plus 6 is 8. 8 divided by 2 is 4. For the y-coordinates, 8 and 0, add them together, you get 4. So at 4, 4. So 4, 4. That one's convenient. Connect my dots here. Not perfect, but decent enough. And then for the last one, average these two. Negative 2 plus 6 is 4. 4 divided by 2 is 2. So for the x-coordinate is 2. And negative 1 is what we get. So 2, negative 1 is right here. Oh, that's just straight down. So it's the intersection should have been somewhere around here. We're going to have to calculate this one to see. So what's the easiest one here? Let's do this one right here and that vertical one. So this equation is x equals 2. That big red line right through the middle is x equals 2. This equation I need to figure out. That's not going to be too hard. The slope equals, change in y went down 3, change in x goes up 6, so negative 1/2. And now I can plug in y equals negative 1/2 x plus b. If I plug in a y and an x coordinate, I can solve for b. So let's just, let's make y equals 3 and x equals 0. Let's use that one. So y equals 3, x equals 0. So then b is going to equal 3. Because that cancels out, so you just get b equals 3. So we do have our slope and our y-intercept for the other equation. So our other equation is y equals negative 1/2 x plus 3. Now that I have those two, I know that x equals 2, so plug it in there. Twos cancel out, you get negative 1. So we get 2, 2. So it should be at 2, 2. I guess those weren't drawn perfectly, but we get our x value is 2 and our y value is 2 for these. So is the answer for that one. All right. Now that we're done here, obviously you can refer back to this for the example, but I am pause the video here, and I'll put the answers up in just a second for 23, 25, 26 as well. All right, so here are the answers for 23, 25, and 26. Conveniently, this one wasn't too challenging, even though we had 1/3. 25, you get a nice whole number. You did have to deal with some fractions. You could have gotten your answer as 11/3 as well, I guess, if you want that on there. So 11 would have been an acceptable answer as well. Hopefully you're decent with mixed numbers and improper fractions. All right, we got one more lesson after this, dealing with perpendicular bisectors and angle bisectors. We'll be doing some of the same stuff, including the algebra. So if you're not quite perfect yet, don't worry. We're going to be practicing some more algebra similar to this on the next section. See you guys for 14-3.